Well, it's US times epsilon t. You see, when t is less than 0, the voltage is 0, which means this is a short circuit. When t is greater than 0, the voltage is US, which means US supplies the electric energy to the load. So this circuit is equivalent to the circuit above, which confirms that epsilon t can be used to simplify the expression of the switching circuit. Similarly, when t is less than 0, the current source is short. When t is greater than 0, the current source supplies the electricity to the dynamic circuit. Seen from here to the left, the whole part can be equivalent to a current source, which is Is times epsilon t. The two circuits are equivalent. Besides epsilon t, we often need to express the delay of epsilon t. When t is less than t0, the function's value is 0. When t is greater than t0, the value becomes 1. This function is called the delay of the time step function, and it's expressed as epsilon t minus t0. This is just the delay of a function which you've learned in the middle school. We suppose t0 is positive. Subtracting a positive delay means moving the function right for t0. Similarly, the definition of epsilon t minus t0 is when t is less than t0, the value is 0, and when t is greater than t0, the value is 1. With the concept of epsilon t and epsilon t minus t0, there are another advantage. We can use epsilon t and epsilon t minus t0 to express some special functions. You see, here are two examples. This is a window function. When t is less than 0, the value is 0. When t is between 0 and t0, the value is 1. When t is greater than t0, the value is 0. So how to use epsilon t and the epsilon t minus t1 to express this window function? You see, we can suppose the function is the sum of two functions. The first function is epsilon t. Of course, it's different from the previous ft. Their difference is the value when t is greater than t0. So we need such a function to compromise with epsilon t. Their sum is the window function of ft. Now let's think, what's this function? It's epsilon t. What's this function? It's a minus value of epsilon t minus t0, so it's minus epsilon t minus t0. So we know ft equals epsilon t minus t0. This conclusion is very important and will be used in the future discussion. Next, we discuss a more complicated function. When t is between 0 to 1, it's a straight line whose slope is 1. When t is greater than 1, it's a horizontal straight line whose height is 1. We can have several perspectives on this function. For example, we can suppose it equals this function plus this function. What's the function in the green line? It just equals the function on the left times t. So according to the left expression, we know the function in the green line equals t times epsilon t minus t epsilon t minus 1. t0 is just 1 here. What's the function in the blue line? Obviously, it's epsilon t minus 1. Then we know ft in the red line equals t minus epsilon t minus epsilon t minus 1 plus epsilon t minus 1. This is the first perspective. Next, let's have another perspective on this function. Firstly, the function can be seen as this line. When t is greater than 1, it's different from the previous function. To make a compromise, another function should be superposed on it when t is greater than 1. The function should be downward and its slope is -1. The slope of their sum is 0, that is, the value is constant. Let's see what's this function. Obviously, it's t times epsilon t. What's this function? It's the negative value of t times epsilon t with the delay 1. So it equals minus t minus 1 times epsilon t minus 1. You should notice that this function move 1 to the right means all t in the expression minus 1. According to this opinion, ft equals t times epsilon t minus t minus 1 times epsilon t minus 1. It's not difficult to verify the two expressions are the same.